Hello students, welcome to Vipin Sharma Physics channel. Dear students, now every video will be uploaded in two versions. One is in English version and the second is Hinglish version. Means in the second version I will be using English plus Hindi, both the terms. Anyway, students, in the vectors, you people have gone through the concept of parallelogram law of vectors addition. Well, I would like to make you to first revise its definition. Parallelogram law of addition of vectors states that if two vectors are represented by the two adjacent sides of a parallelogram, say vector f1 and vector f2, the two forces which are represented by the two sides of a parallelogram, then the resultant vector r is given by the diagonal passing through the same point C, passing through the same point, say O. The two forces F1 and F2, they are acting at a point. Then the resultant R is passing through the point O, which is the diagonal. You can see in my playlist of vectors the parallelogram law of vector additions, and there I have proved that f1 square plus f2 square plus 2f1 f2 cos theta under the root, that is the angle. We have theta angle between f1 and f2. If you carefully observe, students, you get the total concept here when the two vectors, say force F1 is represented along OA, force F2 is represented along OB, then the resultant is represented along OC, and theta is the angle between F1 and F2. OA and OB are the two sides of a parallelogram OABC, and the forces F1 and F2 are acting at a point O, and R is the resultant. Do you remember? Now one of the students asked me, sir, I need some practical example of this. So I have seen children, rather even elder, flying kites in the sky, and you might have seen that the kite, when is being is floating in the sky, it goes up. Okay, how it goes up? Well, I will say it goes up in accordance with Newton's third law, in accordance with the law of parallelogram vectors addition, and in accordance with the jerk also. What is jerk? Jerk is the rate of change of force, right? The force is variable, right? The rate of change of force, that is called jerk, correct? I don't know whether jerk is represented by the letter J or not, but I am writing of my own, right? So the rate of change of the force variable with respect to time is called jerk. What happens in kite? First of all, I will explain how this F1, F2 and 2f1 f2 cos theta, f1 square f2 square plus 2f1 f2 cos theta adds there. Let me rub it once again and let me make it. See, r is equal to f1 square f2 square 2f1 f2 cos theta. Correct? Well, students, how this f1 f2 will act, how parallelogram law will act. This is a kite, you know. So this is a kite here, and when we make the kite to move up in sky, at the back side of the kite you see this, you know. Now look, students, this is f1, this is f2, this is resultant, okay, and this is theta, and see, here is your kite and this angle is theta. You assume that it is a straight line, and it is a straight line like this. So you have here, this is f1, this is f2, and this is the resultant. Now when you pupil just pull it like this, or when you pupil make jerk, in Punjabi we call it tunki, like this, you know, this is called jerk, this is called jerk. When we make jerk, that is ddt of f, that is ddt of f. Now when we give jerk, this, say this is C and this is B, this is C, this is A, and this is your O. When you give a jerk, then CB comes here and CA comes here, theta decreases. When theta decreases, then what happens? f1 square to f1 f2 to f1 f2 cos theta, the whole is increased, okay, and then there is a downward force acting, and to counter that, third law, it goes up. So as we give jerk, it goes like this, 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 theta decreases, it goes up, 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 up. How? Like the rocket, like it gives action in the downward, and air, that is the medium, as you swim in water, like this, you goes up. As you swim in water, you goes up. It's floating or swimming in air, it goes up. That's it. So students, more quickly when you give jerk like this, more faster it goes up, 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 up. And when you pull it with a constant force, it gets continuous downward action force. It continues to move in the upper direction. Isn't amazing? Parallelogram law of vectors means forces. I am explaining just how you fly kite. All right, hope it is clear. So this is your channel, students. I've told you, if you like it, do share with friends and do comment upon it, and can subscribe as well. Thank you very much. God bless you. Bye bye.